Hello, we're going to tackle a very important problem in GMAT statistics. How does a series mean get impacted when you change the series somehow? By changing each number of the series somehow, or by adding new numbers to the series. For example, you have this series of four numbers 2, 5, 7, 8 with a mean of 0.5.5. What happens if you multiply each number by 3? What happens to the mean? Does it increase? Does it decrease? And if you add additional numbers to the series, for example 9, 6, 7, what happens to the new mean of the series? And we are going to look at step by step how to solve questions like this, along with some practice problems to really understand how to apply each of those concepts. Let's get started. Okay, so first we are going to tackle the impact on mean when we are adding new terms to the series, and we'll start with examples so that you understand what is happening here. So here we are given that the original series is 5, 7, 10, 11, 12, and I have already calculated the mean for you, 9, which also means the sum of the series, since there are 5 terms, would be 45. So let's keep that handy. Let's first start with a new series where we are adding this number 3 to the series without changing anything else in the series, and see what is the impact to the mean. So what you see is the new sum would be 48. And since now there are 6 terms, the average would be 48 divided by 6, which is 8. So new mean, which I'm going to call as M2, is actually less than M, which is my original mean. Now let's look at the series number 2, where I'm adding this term 9, which is equal to the mean, to the series, and my new sum is going to be 54, and my new mean M2 is going to be 9, which is equal to the original mean. In the next series, you would find that the sum is actually 55 and the mean is around 9.1, which is greater than my original mean of 9. And in this series, you would see that the sum is 59 and the mean is 9.8, which is greater than my original mean also. So there is something very, very interesting happening here, and there is a pattern here, and I hope you already realize the pattern. Whenever I am adding a number that is less than the original mean, the mean is decreasing. As in this case, when I add 3, which is less than the original mean of 9, my mean actually decreases. Whenever I am adding a number which is equal to the mean, then my mean doesn't change, it remains the same. When I add any number which is greater than the mean, my mean increases. This is the underlying pattern that you need to understand. Let's review this pattern really quickly. The mean remains same when the new numbers that you add to the series are all equal to the mean. The mean increases when the new numbers are all greater than the mean. And finally, the mean decreases when the new numbers are all less than the mean. However, in a question, it could be a mix. Some numbers could be greater than mean and some numbers could be less than the mean. How would we tackle that part of the problem? Let's look at it next. So here we have the same original series with a mean of 9 and, as you recall, the sum of 45, and we are adding additional terms to the series. However, in this particular case, for every new series, some of the terms are greater than the mean and some of the terms are less than the mean. So it is not very straightforward what will happen to the mean. So let's look at this series. For example, the sum is going to be 61 and the mean is going to be 8.7. In this series, the sum is going to be 72 and the mean 9. In this case, the sum is going to be 63 and the mean is going to be 9 again. In this case, the sum is going to be 64 and mean is going to be 9.1. So let's look at the underlying pattern, what is happening, and is there any way for us to really look at the new numbers that are being added and predict what will happen to the mean. Okay, so let's look at the first series. In the first series, in the original series, we are not changing anything, but we are adding two numbers 3 and 13. And what you see is the mean of this new series is less than the original mean. So the underlying pattern that I want to point out is, if you calculate the mean of the two numbers that have been newly added to the series, which in this case would be 3 plus 13 divided by 2, which is 8, and that average is less than the original mean, then the mean will decrease. With the same logic, if you add the numbers whose mean is same as the original mean, then the mean should remain same. So in this particular series, you can see that the mean has remained same as original mean. The average of the new numbers divided by 3, because there are 3 numbers, would be 27 by 3 is 9. So when I calculate the mean of the new numbers, I found that the mean of the new numbers is 9. Hence, the mean of the series will not change. Similarly here, is 18 divided by 2 is 9. So the mean of the new numbers that I'm adding to the series hasn't changed. Hence, my new mean is same as my original mean. In this particular case, the new numbers that I am adding are 2 and 17. So the mean of those numbers is 9.5, which is greater than my mean. My new mean M2 is greater than my original mean. So a couple of things here. I hope you understand the pattern now. You have to calculate the average or mean of the new numbers that are added to the series, compare it with the original mean, and figure out if the mean is going to increase or decrease. However, you cannot predict what the final value of the mean would be. As you can see here, the mean of the two new numbers is actually 9.5. But my new mean is 9.1. So the calculating the average of the two numbers would only give you the direction in which the mean is going. Would it go higher or lower, but not the exact value of the mean. So let's quickly review step-by-step process. So this is the step-by-step process on how to approach problems like this, where there are new numbers being added to the original series without changing the original series. So in the first, you would add the two numbers. So in the first step, you will add the new numbers together. So in this case, we are adding the two numbers together as 16. Similarly, here we would add them together 27, and here we are going to add the numbers together as 19. Now we find their mean. Let me quickly write down the means, and we then compare with the original mean. So 8 is less than 9, and finally we apply the rule that if the average of the new numbers added to the series is less than the mean, then the mean will decrease. If the average of the new numbers is equal to the mean, then the mean remains same. And if the average of the new numbers is more than the mean, then the mean increases. This is the step-by-step way to solve problems like these. And let me take you through a solved example where we are going to apply all of these concepts to get to the answer. So here is the question. I recommend that at this point you get your notepads ready and actually try to solve the question on your own so that you can practice the step-by-step method that we just completed. I hope you got the right answer. However, let's go step by step. So we are given a series of 8 numbers and the mean is given to be k. It is a good thing that we are given that k is not equal to 0, because 0 creates some complications. And we are also given that we are creating a new series out of this old series or original series, and those numbers are minus 3k, 2k, and 4k. So we have two series. Series S has 8 numbers and series S1 has 8 numbers and some additional numbers which are minus 3k, 2k, and 4k. We are asked to find the ratio of the average of S1 to S. Now we are going to follow the step-by-step process. The first step of the process was to add the new numbers. So when I add, I get 3k. Then find the mean of the new numbers. So that would be 3k divided by 3 equals k. And then compare the mean with the original mean. So the original mean was k and the new number mean is also k. So the original mean and the new means are equal. Since they are equal, the mean of S1 would be equal to mean of S. That means their ratio will be 1, and hence C is the answer to this question. The ratio of the mean hasn't changed, and hence the ratio would be 1:1. So here is a quick review. We follow the 4-step process that we talked about. When new terms are added to the series, we follow this 4-step process and apply the rules. And the rules are, if the mean of the new numbers is same as the mean of the original series, then the mean of the new series is same as the original. If the mean of the new numbers is more than the original series, then the new series mean is also more than the original series mean. And finally, if the mean of the new numbers is less than the mean of the original series, the new series mean will also be less than the mean of the original series. However, this is not all. There could be other manipulations that can be done to the original series, and that could also impact the mean, and let's look at that. Again, my original series is the same as before, my mean being 9 and my sum being 45. In the first case, I am adding 3 to all the numbers in the series, so 5 plus 3, 7 plus 3, and so on, which gives me a new sum of 60, which brings my new mean to 12, which is actually nothing more than 9 plus 3, so original mean plus. Now let's subtract the same number 3 from all of the numbers in the series, and I get these new numbers with a sum of 30 and new mean of 6, which is nothing but my original mean minus 3. Similarly, when I multiply each number by 3, I get a new mean of 27, which is nothing but 3 multiplied by my original mean. And finally, I will get a new mean of 3, which is nothing but my original mean divided by 3. So what is happening here is, when I'm adding a constant number to all the numbers in the series, the mean also gets added by the same number. When I'm subtracting all the numbers by a constant number, the mean also gets subtracted by the same number. When I'm multiplying the same number across all the numbers in the series, then my mean also gets multiplied, and similarly the mean also gets divided when I divide each number by the same number in the series. To quickly review, when you add k to each term in the series, the new mean is just original mean plus k. Similarly, for subtraction, it would be original mean minus k. For multiplication, it would be original mean multiplied by k, and for division, it will be original mean divided by k. It gets a little bit tricky when you get to standard deviation. However, these are the rules for mean. I hope you liked this video and found it helpful. Please do not forget to press like and subscribe to my channel for more such videos. Thank you very much. Have a great day.